There. Let's find an equation of the tangent line to the graph of the function at a given point. For example, we have y equals to x squared e to the power x minus 2x e to the power x plus 2e to the power x at the point 1, comma e. So to find the equation of the tangent at this point, we first need to differentiate this function. From there, we find the gradient. After that, we are going to find the tangent line. So the differential of this function is the same as the differential of this function minus the differential of this plus the differential of that. Okay, so the differential of this here is the same as multiplying the differential of x squared with e, then you add the differential of e multiplied by the x squared there. So to do that, we are going to have the differential of x squared will be 2x multiplied by e, then plus the differential of e is just e. The differential of e to the power x will be just e to the power x multiplied by x squared. So if you don't know how to differentiate e to the power x, just to watch the previous video I made. I've explained how to differentiate e raised to a power. After that, you are going to have a clear picture of what is happening here. Okay, so we move forward. The differential of this one here will be the 2x, the differential of 2x multiplied by e, then plus the differential of e, which is e to the power x, multiplied by 2x, which is this one here. Then from there, we are going to add the differential of 2 e to the power x, which is the differential of 2. Remember, the differential of a constant 2 is just 0. 0 multiplied by e to the power x, we are going to have a 0 here, plus the differential of e to the power x is e to the power x again, multiplied by 2. We are going to have 2 to the power 2e to the power x. Then from there, we open the brackets. After that, after opening the bracket, this will be 2x to the power e, and then this one here will be just the same, but here we are going to have a negative multiplied by 2 to the power 2e to the power x, which are going to have negative 2e to the power x, and then this one here is a positive multiplying with that negative there. We are going to have negative 2x e to the power x here, and then from there, this one will be plus 2e to the power x. Okay, so from there we have these 2x to the power e to the power x here, which will just cancel or subtracted by this one, and we are going to get a 0. And then from there we have this one here, which is a negative, plus that we are going to have a 0. So our differential, or the differentiation of our function, will be just this one here, which is x to the power 2 e to the power x here. So that is our dy dx. From there, let's now find the gradient at the point 1, comma e. So to find the gradient, we are going to replace our x value in our dy dx function. So replacing where there is x with 1, we are going to have 1 to the power 2 and then e to the power 1. Then from there, simplifying that, we are going to have our dy dx at the point x equals to 1 is going to be just e. So we know that our dy dx is equals to m, which is in this case e is e. So to find the equation of the tangent at the point 1, comma e, we are going to replace our point, which is 1, comma e, in this equation, which is y minus y1 equals to m, which is the gradient, x minus x1. Now in this case we have our y1, which is e, and our x1 will be that one which is there. Okay, so I'm going to replace the values of y1 and y and x1 and our gradient in this function. Remember, our gradient was e and our y1 is e and our x value is 1. So to replace that in our equation, we're going to have y minus e, which is our y value, y1 value there, and equals to m, which was our gradient here, our gradient, and then from there our x1 value is just 1. So we are going to replace it there. So simplifying this, we are going to have e here. We are going to have y minus e equals to e multiplied by x will be ex, and then e multiplied by that one there, we are going to have our e there. And then from there, moving this e, which is this side, to the other side of the equation, collecting the like terms, we are going to have y equals to ex minus e plus e, which this will just result in a 0. So our equation of the tangent for this function will be just y equals to ex. Okay, so thank you very much for watching this video. Remember, don't forget to like, subscribe, and leave out your comment in the comment section below so that you don't miss any of my videos.